Hello everyone, I'm back with my next lesson. So I'm on 11-3, 11-3, which is on page number 832. And today we're going to be learning about finding areas of different shapes. So we have done rectangle, square, we have done parallelogram, so a few more examples. So today we're going to be learning about finding areas of trapezoid, and rhombus. Okay, first let's try understanding how each shape looks like. So when I say trapezoid, what's so special about this shape? This is still called a parallelogram because normally we see two sets of parallel lines, but in a trapezoid we see one set of parallel lines. So let's say you could even see something like this. That could be an example, or it could be like this. As long as you see one set of parallel lines, that's a trapezoid. Okay. Now, so the idea is the equation we're going to be using to find area is 1/2. Still, it's going to have height in there. But what's going to go in parentheses? It's going to be B1 added to B2. Where B1 and B2 is nothing else, that just those going to be base sides. Alright, so how to identify each one, so we'll talk about that. But first of all, if I say, I don't know if you remember, I said basically base times height is the foundation for all of these equations. So this is more like triangle equation because I see height, 1/2, I see height. So this is, instead of having just one base, I have two bases. Why two? Because if you look closely, for this type of shape, I see two sets of parallel lines. So basically, I have two different bases of that. But why do we need to add? And why this equation looks like triangle equation? So that's what I have to show you here. So think about this. If you have, normally, a trapezoid looks like this. Right? So pretend if I just slice something out, if I cut this piece here, if I take this whole slice and place it here, can't go further, but anyways, yeah. If I put this slice and put it here, so what do you see? So pretend this is not even there, I put it over here. So technically what I see is, let me pick a different color. So what I see is, it's a triangle here. So how do we find area for triangle? It's basically you got to take the base, which is going to be this length, going to be, let's say this is my base 1, this bottom one is base 2. So technically this is this top base that goes down here. This is base 2. And how do we find height? So you got to look at the altitude, right? So that's the reason this equation looks similar to triangle, because basically what happens is at the end, if you slice that out, if you cut that piece and place it on the other side, this becomes a triangle, okay? So let me show you an example. So let's say there is a trapezoid like this. So I have 300 here. So keep in mind, the height going to be the one that makes 90 degrees on the base. All right. So this is 300. So that's going to be height. So then I have 205 for this side length. I have 511 for this. So you need to find the area of this shape. So I know it's a trapezoid. So area equation going to be 1/2. So you're going to take base 1, add to base 2, because eventually base 1 is going to get added to base 2, and the height. So 1/2, base 1 is 205, doesn't matter how you put, you can put 511 first, doesn't matter, and times it by 300 if you put everything together. So your answer would be 110,622. Let's say inches, so I would say inches square. So that's how we find area for trapezoid. Okay, next one, rhombus. First, let's try understanding what is a rhombus. A lot of time people get kind of confused with square. So square, rhombus, a lot of similarities, but still a few differences. So when it becomes, let's say, when I say square, so yes, all four sides going to be congruent. But what else that's true about square? So at all four edges or vertices, it's going to be 90 degree for sure. You have to have like that. If not, then it's not a square. Instead, it's going to be a rhombus. So as I said that before, so yeah, all sides same. So when it becomes a rhombus, for sure, it's all four sides going to be same, but you do not have to have 90 degrees on all four edges. As long as you have all four sides the same and it's different than 90 degrees on all four edges, it's a rhombus. I would say it's more like a diamond. All right, so a diamond is a rhombus. So what happens is, normally these opposite sides are always congruent, always. That's what happens. And you would even see diagonals there. I hope you know what it means by diagonal. So when you connect two opposite edges or vertices, it makes a diagonal on the shape. Okay, what's the equation? So just like the last one, I'm going to give you the example for equation first. Then I'm going to talk about the reason why it's so. So let's say, okay, so but anyways, this is the equation first. So area equation is 1/2 times it by D1, which is the first diagonal, times it by D2, which is the second diagonal. Okay, how come this is the equation? So let me draw a rhombus for you guys first. Rhombus is like this. And we see two diagonals like this. Okay, let's say if I ask you to cut this slice and place it on top of this triangle, isn't it? This would become like that. Okay, same thing on this side. If I take this piece and place it on top of this triangle. So what I see is, okay, fine, let me just outline this. So finally what I have is a shape that looks like this. I hope this makes sense to you. So what I see is one of the diagonals stays the same. So that's the reason one of the diagonal will stay the same. What about the other diagonal? Is it still full length? No, it's not. It's just half length. For the other diagonal, it's just half of the length. So that's the reason one diagonal, which is D2, would stay the same. For other diagonal, you just have to take half of that. So that's how we find area of that area of a rhombus. Let me show you an example. So let's say I have a rhombus like this. So I have, oh, you know what? Another example I would say, rhombus is like, it's carpool sign. If you go on highway, every carpool sign is a great example of a rhombus, okay? Anyways, so what I see is this one here, this one here. So I would say this is 3, this is also 3, and this is 5, and this is 5. Okay, so in order to find area of this one, you have to have both of the diagonals. So one of the diagonal is 5 plus 5 is 10. Other diagonal is 3 and 3, which is 9. So you know, at the end you need to take half of this. So 1/2 10, and then 9. If you multiply together, it's going to be 45. Here you go. So that's how we do it. Let me show you one more example, and that's pretty much all. So let's say it's a carpool sign. Gosh, I am not a good drawer, but anyways, I can't draw straight lines. I'm sorry, too hard for me. Anyways, what I see is, so this piece is 2.5, which is from here to here. And this side length is 6.5 feet. All of these measured in feet. And yeah, this is pretty much all I know. So I have to find area of this rhombus. Again, if you remember, what we need is, we need both of the diagonals, and we're just going to multiply by 1/2 at the end. Do we know one of the diagonal? Yeah, because what I see is, let me pick a different this one here. If this is 2.5, this is also going to be 2.5. So I know one of the side length or one of the diagonal is 5 for sure. Do we know the other one? No, we don't know any of those. But instead, I know this outer side. So if you look closely and keep in mind, wherever those two diagonals going to intersect, it's going to be 90 degrees. So technically, this whole shape is a right triangle. And I know two sides of this right triangle. So can we figure out this piece here? Yes, we could do that. So we could do a square, b square, and it's equal to c square. So let's plug everything in. A square, so let's just say 2.5 square. B is missing, and c square, which is the hypotenuse, it's on the other side. So I would say 6.56 square is, it's 42.25. 2.5 square is 6.25 plus b to the second. So b squared going to be equal to 36, and eventually b is equal to 6 here. So if this piece is 6, this is also, I know it doesn't look like, but assume it is. So you already know 6 and 6, that's going to be 12 for the other diagonal. And finally, my answer would be 30 feet square. So that's how we do that, okay? I hope you understand. If you don't, my bad. If you don't, you can always go back, pause the video. You can go back and watch those videos, the whole process again. So guys, thank you for watching. Thank you. Bye-bye.